Good day, folks. I hope that you saw the last video I did regarding the database, but now I want to advance on my analysis regarding the fertilizers use in Brazil, the lack of capacities to supply all the demands that we have, and also at the end the efficiency regarding the use of those fertilizers which we import. I just want to share with you some of the slides that I prepared for this part 2. I will focus on the nutrients demand in the Brazilian crops. Yes, Brazilian crops are mostly soybeans and corn. Well, I'm saying that because this is the great majority of our land use and our production. So exports in Brazil are extremely focused on soybeans and corn. Okay, so that's the reality. And I can tell you that for those which are not familiarized with the fertilizers and the nutrients that all plants need, they need nitrogen, phosphorus, and potassium. These are the main macronutrients. There are other nutrients very important, like secondary nutrients and the micronutrients. I will not focus the majority of the imports, and the main cash disbursement for fertilizers regarding nitrogen, phosphorus, and potassium. So if you have a plant, of course, the plant needs water, it needs sun to realize photosynthesis. But what I'm doing here is just to bring you to this environment, to this world of nutrients. In this presentation, we will see the general view of the key macronutrients demand, how we calculate it, using the database which I explained in my last presentation. And I will also show you some concepts like the export and the deduction of nutrients exports. Let's see what I'm saying here. But first, let's get an overall view of the crops we have here in Brazil. So we are talking about the harvest 22-23. If you understood the database, I don't need to really come back here. But what we have here in terms of production, 1,000 tons, we can see actually what we see here is the proportion in terms of output. So soybeans represent almost 50% of all grain production. Weight, final product, and corn or maize, it's around 42%. So we are talking about 90% of the Brazilian production. In this study, we didn't include something like another 8% of the production here. There are other crops which are not really relevant for our study, which are not included, but please consider this as the whole Brazilian output. And here we can see the total area. And the total area, we see the same. I just come back here to show you that soybeans represent more in weight, but they represent, less in weight, but much more in terms of area. It doesn't change dramatically the situation, but corn has much more weight in terms of production than in the area occupied. So here, going back again to the total area of harvest 22-23, and then we can see 87 million hectares, of which 8 million were related to sugar cane, which is not a grain, and 78.5 million hectares for all the grains which I mentioned before. So here we can see the total production, 931 million tons, but it is completely distorted this year because we did have 610 million tons of sugarcane output in this year. So the total grains, which we should focus actually, is 320 million tons in this year of 22-23. This is my main output that I have from CONAB. CONAB is a Brazilian agency. It is a governmental agency which takes care of the output and has some logistic activity in terms of distribution. Nevertheless, they do a very sound and reliable statistic regarding harvest. And that's what we see here. It is summarized in the corn, soybeans, cotton, wheat, rice, beans, sorghum. So these are the grains which I really follow, track. And then we do have other outputs like sunflower, mamona, oat, canola, barley, rye, and triticale. So these are the crops which I follow, but the 7: milho, soja, algodão, trigo, arroz, feijão, e and sorghum. These are the main grains. And then we do have in a different line, outside the grain subtotal, we do have sugarcane. Then you can see the same figures which I showed before. You see the area, the production. So everything is conciliated in my database, as I explained in the other presentation. So here it is. We do have many variables like production, area, yield in this CONAP data. And here we see a different thing, which I should take some time to explain. Once you do the harvest, you take away from the plant and its content, you take great part of the nutrients which we applied before the growth of the harvest and before the growth of the crop. We expect when we make the cut, we harvest things, we expect to get a certain amount of mass regarding these main nutrients: nitrogen, phosphorus, and potassium. And what we see here in the middle column here, we see a kind of reddish, the three columns detailed data that we present here are the kilograms per ton of harvested crop. So we have, for instance, in the core, we have nitrogen 4 kilograms per ton. When we harvest, we also get 2.6 kilogram of phosphorus and 3.7 of potassium. But these are elements, the content of these elements in the material we get from the crop. So I hope that I did explain you. If you are not familiarized with this concept of exports. So when we do the harvest, we get these figures. You can see that in red. And these are the most important figures to create the last column that we can see there. It is the exports in 1,000 tons of each element. So if we go, for instance, to soybeans, we get 9,153,000 tons of nitrogen. That's the element that we get when we do the crop, when we did the crop of 22-23. And this estimate is, of course, very important, since they will point us the amount of fertilizer that we need for this kind of crop in a specific year. Nitrogen is a very specific case in terms of soybeans. And I will comment this a little bit later. So when we see that, we can see the amount of nitrogen and phosphorus exported and potassium exported. One remark here is that when we calculate the exports of phosphorus, for instance, we use the phosphorus pentoxide concept, and then we have to multiply the amount of phosphorus that we get from the element in terms of pentoxide, phosphorus pentoxide, not in terms of phosphorus, because this is not how we trade fertilizers worldwide. So exports of fertilizers, in terms of nitrogen, there is no difference, but in terms of phosphorus and potassium, we do have a difference. In terms of potassium, we use potassium oxide, and then we have to multiply by 1.2051. In terms of phosphorus pentoxide, we use 2.291 to convert phosphorus to the pentoxide or potassium to the potassium oxide. So here we are multiplied by these red numbers. You can see 2.291 and 1.2051 on top of these tables. So the database has all things already converted, but nevertheless, it is important for you to understand how we really calculate. So in the bottom at the right, we see that nitrogen, we're gonna get 12,160 tons of nitrogen exported, and just 3 million and 4.9 million in potassium. Phosphorus and potassium respectively. But this is a very interesting thing because what happens is the following. There is a bacteria which help us to save nitrogen, and it is regarded as nitrogen fixation, biological fixation in the soil, which allow us to not really replenish all the nitrogen that it is theoretically just extracted during the harvest. So these 12 million is not really needed because there is this biological fixation of nitrogen. And some other crops interact with the soya production because they are used in rotation or in we call that rotational crops. But the fact is that these 9 million that we see there of nitrogen exported for soya is actually 100% fixed in the soil. And we don't need actually to restore that or to, again, import and distribute new nitrogen fertilizers. That's a very important economical factor for the soya and other nitrogenous intensive cultures. So for you to understand, we see here the production, we see here the theoretical exports, we see the theoretical exports in absolute amounts. And then we can see here that on the left we see the same figures, the amounts of exports, and in the middle we see the deductions that we have to do on these exports. And you see that 100% of the all soya is not really needed, so we have to deduct that from the total amounts. And then we have other cultures, which we have some indications from IP&I, which allow us to estimate really the total need of nitrogen, potassium oxide, and phosphorus pentoxide. And we see that in the left, in the right column. And these are numbers which I did for 22, 23. I did that for since 2017. I don't have other calculations done by IP&I after 2016. So I did that by myself. I have I use the same criteria, and this is very important because we can, with these figures, we can understand why do we need much less nitrogenous fertilizers than what the theoretical exports would recommend. Okay, so very important concepts here, which are by the agricultural experts already established. And of course, this is a general macro view. Each location has its own characteristics. But as we can see here and understand the dependency of Brazil regarding imports of fertilizer and how much do we need really to care in the future. So, in the next steps, we will see the fertilizers use efficiency. According to the IP&I Institute, they did that study since 1988 until 2016, and I did the same calculations after 2016. And I checked all the data. They did that before me, so I guarantee you that I'm using the same criteria they used. That's what we do have in our data set. Understanding the fertilizers, consumption, imports, and local production, that's next steps. And then estimate really the dependency on imports. So these are the next steps. At the end, we will see where do we have really opportunities in terms of main macronutrients optimization in Brazil. Many has been said and about these potential, and this is a key number for any investor willing to put money on new plants of nitrogenous fertilizer or new mining or mineral operations of potassium. Okay, so said so. That's more or less this short video which I would like to share, which I wanted to share with you, and I hope that you enjoy it. Until then.